Hello everyone, just a quick disclaimer. This is kind of a long one, and so I'm going to put some links to where you can jump to the different topics that I talk about in this episode. Because I ramble a bit and I just wanted to get this recorded and out to you. I missed a video yesterday, so yeah, I'm secretly doing a Veda right now, so I'm trying to make a video every day in August, as it's called. But anyways, you should see some links here. Click them if you want, or don't, and just watch it. That's cool. So let's start. Hello, and welcome to this, the final prologue lesson of this vlog series. Alright, so in this episode, this might be a long one. As you can see, there's a bit of new code here already. Because I wanted to set up some things beforehand before we get into the book. And that's because, as I said before, the book is using processing, and we are not. So we're going to make it like processing. And how are we going to do that? We're going to set up our kind of game loop right here. And then also kind of a draw cycle within this loop. So let's get to it. I'm going to erase all this for now. We'll get back to that in a second. And also last time I fumbled around and had to search through code to figure out how to do all this, but hopefully we won't have to do that this time. And maybe it'll go a little bit more smoothly. Although hopefully I'll still make some educational mistakes along the way. If that makes sense. If that makes sense. Yeah, I think I said that a lot, but you know, it's my style. Alright, and I think we might have some, let's see, project. No other classes or anything in there. Alright, so the first thing, do you see something wrong? Sure you do. I am missing a bracket. Okay. Of course, you probably saw that before I did. Okay, so before we get to making our game loop, I want to talk to you about the project.xml file here. So let's pop that open. As you can see, it's already open there, but let's do it real quick. And I'll zoom in a bit for you. So basically, this is what we'll use to, change the settings of our player, be it Flash or a native Windows or anything like that. And you probably don't have this line here yet. You'll probably have to add it, but usually with some other libraries, they'll put that in for you, especially with like Haxe. They'll set that up for you. So let's just take a look at some of the attributes we can set. Let's just look at the website. So with this, you can set the width, height, background color, frame rate, and then also some other things like whether it uses hardware acceleration, whether it allows shaders or requires shaders. You can take the border off of the player. You can set whether it's resizable or not. So let's pick a few numbers for that. So let's do 800 by 600 for our player size. We'll run at 60 frames per second. Let's change resizable to false. Yeah, if you saw it was a true or false, so that's how we'll switch back and forth between those. Resizable, yep. And borderless, we'll keep that as is. VSync false. I don't think we want that. Alright, good. So now if we run it by hitting F5, it should be a 800 by 600 white box that can't change size. Alright, that looks like it's changing size. So, I don't know, maybe it's not so much the window changing size, maybe the stage on the inside is staying the same size, technically. How about background color? Background color. Is that what it was? Or was it just background? I should have paid more attention. Yeah, just background. And then a hex number. I think we can use our color picker for that. Insert color. I'm gonna pick a nice warm color like that. And we have this style of hex, hex number, but we'll just take out the 0 and X and replace it with a pound. And there we go. Yeah, it's resizing. Okay. Well, that's what we're going to start with. Okay. So next, let's make our loop, our game loop. So in other kind of programming languages, you'll essentially have like a while loop or something, and then it'll go through that loop as many times as it can, and it will change stuff and whatnot. But I think a while loop will lock us up in this language. But since we're based on Open FL, which is kind of based on Flash, it thinks of it more as like the Flash player. So the Flash player is already playing frames, so what we're going to do is use the frames for our sort of timer to make our world move. So let's set that up. So Flash uses the things called events, and with these events we put listeners that listen for these events, and when these events happen, the listener does things, and it does things by running a function called a handler. So how do we listen to these events? Well, easy. Since this is based on the sprite class, it can listen to events. So we need to add a listener to it. So how do we add a listener to it when we're in it? We put this, which references this sprite that we're making, this main class, and then it has a function called add event listener. And then it's going to take a listener type, and these are mostly stored in a class called event. And we can import event by typing event and doing Control-Shift-1, and it will automatically import event for us. And within this class there's a a variable called interFrame right here. There. So every time this interFrame event fires, this listener will act. But what will it do? It will do this right here, which is the handler, the function that will run when this event happens. So we're just going to call this loop like that. And then, again, using Flash Develop, which is very handy. I know that not all of us have it, but it's very handy. You will do Control-Shift-1, and we're going to generate an event handler. So let's talk about what it generates real quick if you don't have Flash Develop. So if you were to just type loop here, that would be okay. We would just come down below and make a private function or a public function with the same name. It has to have the same name. And since this is an event handler, it needs to take in an event, and it won't return anything, so we'll just put void right here. And I think there could be a case where it could return something, but I think in this case it will not. What this event object is sometimes these events, let's just test it out real quick. Event dot, oh, is it not going to suggest anything? No, okay. In that case, let's come up here. Event dot, okay. These are all different things that can happen, right? Sometimes you'll have things like okay, maybe not this particular event, but there's something like I think there's a mouse event. Mouse event. Okay. Okay, so we have in this mouse event class, in this just so we can talk about events a little bit, it has something like click. I haven't used it before, but I'm pretty sure. You might want to look it up just to double check me. I'm pretty sure like when this mouse event happens, the click, you will like let's see, yeah, or mouse down or whatever. It mouses down over something, right? So when this event happens, inside of this little event bit of data, it might contain what was moused down over. So you can use this, and you can be like e dot, yeah. See, there's little target. I think. See, like in the case of the click, maybe it will have what was targeted on the click, for example. All right, now that I've rambled on about unimportant things, let's move on. So we're gonna do interframe here, and here we have our loop. So just to give this a quick test, let's do trace loop is running. Give it a run, F5. And there it goes, loop is running, and it'll just continue running like that. Oops. Did I just close? Oh no, there it is. That was weird. My computer is weird. I think it's because I'm running Vista. For some reason, I always get a new computer when the crappy version of Windows is out. My other computer is a Windows 8 computer, so go figure. Anyways, so this loop is running at approximately 60 frames per second, as we set in the project.xml. But it might not always run at that speed. So how can we be sure that it is, that our game will run at a speed that is independent of how many frames are clicking per second? What we're going to make is called a delta time based timer. I think, well, delta time is the key word here. And if any of you took math in school, delta usually is it a Greek letter? I don't remember. That represents difference. So it's a difference in time. So let's make a couple of variables. So we'll do a private variable previous time. I think that'll be an integer. And then we'll do a private variable elapsed, which will be a float. So computers usually work in milliseconds, but with this elapsed time, we're going to be working in seconds, essentially. So let's do that. So first, what we're going to need to do is get what our previous time is. And to do that, inside of this, let's get our timer. I think I can just type it here. What is it? Lib. Whoops. Nope. What if I do Control Shift 1? Okay, there it is. Yeah, so lib, and then Control Shift 1, and it'll import OpenFL lib. Inside of here we have get timer, like that. So if we hover over this, we can see that get timer returns an integer to us. And that integer represents how many milliseconds have passed since this program started running. So from here, if we just do in our loop, let's just trace get timer. Trace get lib get timer and run it. There it goes. So yeah, it's just counting up the milliseconds into the future. And yeah. So yeah, so essentially these first two digits here are how many seconds this has been running. Alright. So yeah, that runs independent of frames. And actually, if we could pause it, you would see that it's not counting by one, because quite a few milliseconds are running in between each frame. Why does it do that? Okay. Alright. So, we have our previous time, and it's going to, we're going to keep our elapsed time there. So let's make a little function. It'll be a private function delta time, and it'll just be void. Yeah, that should do. Or, yeah, that'll be fine. So, what will we do each click? So essentially what we're going to do is we are going to take the current time, var current time, that'll be an integer, will equal lib get timer, right? And then our variable delta, or the difference, will equal current time minus previous time. Whoops. Minus previous time. Okay? And then, so this will tell us how many milliseconds there are per in this click. So let's see. Let's you know what? Let's return. Yeah, let's just return the delta. So we're going to return an integer, and we're just gonna first, before we return it though, so var delta equals current time minus previous time, and then previous time equals current time. So we're storing our current time into the previous time so that the next time this runs, the current time will be the previous time and whatnot. And then we're going to return, let's return delta like that. Return delta. So if we trace delta time, we should get a number that is, whoops, function. Why is it saying function? Because you don't have that. Because if you don't have the parentheses, essentially you're sending the actual kind of data of the function rather than running the function. So let's try that again. There. So yeah, doing about, what is that, somewhere between like 16 and 20, low 20s per frame. So how can we convert that into to seconds? What we'll do is, I think we will divide by 1000. I hope that transitioned well enough. I had a super brain fart, and let's not talk about it. Anyways, let's run this and see what it does. So, there we go. We're essentially putting the amount of milliseconds over the amount of total milliseconds per second. So that essentially gives us a decimal representation of how many seconds that we are running. So essentially, if we have something that moves 500 pixels per second, we multiply it by this number, and essentially we will have how much of that 500 pixels it should move each frame, if that makes sense, which I hope it does. Alright, but you know what, since I've had some time to think about it since that cut, let's actually have delta time return this, or let's have it, set it to elapsed like we're supposed to. So elapsed equals, was it delta divided by 1000. So now each frame delta is gonna do that. And let's make this public, just for the hell of it. We might need it to be. Okay. You know what? I just realized something. So, we need delta time to be running each loop, so that it'll set all these things. So we actually don't need to return anything, because delta time doesn't work like that. So let's get rid of that, and we'll just put our result into elapsed, and it'll be the elapsed seconds number. Okay, so we have our delta timer, we have our Windows set up. So let's is that all we need for now? Actually, let's set up drawing things. Okay, so let's make an object. It's going to be a really simple object, but it's going to, show us how to get things drawing correctly. Alright, so let's make a new class, and it'll just be something generic. Let's call it a box. Boxy. Let's call it boxy. And a box is a thing that's going to have a position on the screen, and it's going to move around willy-nilly. So, when designing a new class, we need to think about those kinds of things. What does it do? What kind of things do we need to describe it doing those things, right? So we said it has a position, right? So let's give it a position. So let's store our position in we'll just do a public variable for now, and it will be a point. We could store the x and the y separately, but yeah, let's just use this. It's going to be, let's call it position, and it's going to be a point, and like that. So OpenFL geometry point. Okay. And when we make a new boxy, oh, and also, this box has a size, right? So let's also store the size in a point as well. So public var size point. So it's a width and a height. You can think of it that way. So when we want to make a new boxy, we want to give it some arguments. We'll do, we'll do x position, which will be, I think a float is okay. Actually, that's a good question. What do floats have in them? I guess we'll figure out in a second. X position, Y position, and then it's going to take a width, which be a float, and a height, H-E-I-G-H-T. Is that right? And that'll be a float. Okay. And when we do that, we're going to say position equals a new point. A new point. It should be suggesting something. I thought it would anyways. Am I doing something wrong? New position equals new point. Well, let's just type X position, Y position. I have a feeling I'm messing something up here. And size will equal new point, width, height, like that. Okay. And something I didn't talk about earlier. Let's say we don't want to always have to type out, when we make a new box, we don't always want to type out the position and the size. But we're pretty sure that when we make one, we want it to be at 0, x and y, and that it will be 16 pixels wide and tall. So here, if we put this will be the default. So I think if it comes in as null, it will put in this value in its place. So let's try it. So here, let's close that. In our main, let's make a public variable box of type boxy, like that. Actually, let's put it in here. So box equals new boxy, and we'll just take the defaults for now. Okay. And then let's just trace box dot position dot see, points aren't working like they should. Okay, I thought points had a x and a y property. Well, let's see what happens. Dot x, and let's run it, see what happens. Build succeeded. Okay, 0. Width, oh no, size dot x. Oh, that time it came up. Maybe I just had to save and run it. And it should say 16, right? Okay, all right. So points work exactly how I expected. So we are creating this new box. and it has a position, an X and a Y, but I don't see anything. What's up with that? So what we're going to need to do is... that's so annoying. And now it comes back by closing that other window. Oh god. I hate you, Vista. Or maybe other Windows versions do that, but I've never seen it. Anyways. Alright, so we have this box. It has a position and a size. So how do we get it on screen? So in our loop, let's draw it to the screen. And how do we draw it? So this is of the sprite class, and sprites in Flash have a graphic in it. So I think if we put graphic, do I have to do this? Maybe I have to do this. Graphics. Yeah, this graphics. And with this, you can draw and do all kinds of things like that with it. So let's do this. We'll write this, and yes, we're gonna begin drawing a box, right? So this graphics, what you have to do is first you have to begin fill. This is what you use to, draw fill shapes in Flash, and maybe you're familiar with the tool. Drawing tools in Flash, you have your fills and your lines. So basically this is starting the fill. And then we're going to draw our stuff, and then we're going to... Can I just write graphics? I thought I could. No, I can't. This end fill. Oh, graphics end fill. End fill. Okay. So in between begin fill and end fill, let's draw something. So within the graphics, this graphics, we're going to draw a rect. And this will take in an X, Y, a width, and a float. So we're going to take boxes position X, boxes position Y, boxes size X, which is our width, and boxes, I keep doing it, size Y. And that's how we'll draw a box. So if we push play, we get errors. We're missing a semicolon. Where are we missing a semicolon? Right there. And we hit play. And not enough arguments. Where are not enough arguments? This graphics begin fill. Really? What kind of arguments do you need? I'm pretty sure you don't need arguments. Let's take a look at that again. Color and alpha. Oh, right. So, yes, when we begin fill, we have to say what color we want. So, that will be... I wonder why it's not suggesting that, though. That's weird. Oh, there it is. So, let's see. We have an orange background right now. Let's insert a color. Orange. Let's go for like a really kind of unsaturated blue. It'll just look gray in comparison. And then alpha, which is a float, I think we just write 1. Right there. Oops. Okay. And now when we run it, hopefully I've done it correctly. Look, there's our 16 by 16 gray box. But it doesn't do anything. So, let's have some fun with that. So each time we move through, let's move this box at 100 frames per second. Does that sound good? So each time we go through, we're going to take box's position x, well, plus equals 100 frames, or 100 pixels. I said frames per second earlier, didn't I? Anyways, 100 pixels per second. But right now, it's going to move at 6,000 frames per second if we do that. So I think it's probably just going to disappear as soon as we, yeah, see it. Oh, yeah. So each frame, it moves by 100. So it's out of there. But that's a little too fast. So to move it by 100 pixels per second, we need to multiply it by our elapsed, like that. And then when we push play, it should more casually slide across the screen, like that. But I know what you're thinking, Chris, why is it drawing a line rather than moving the box? Well, that is because we need to clear the screen first. So this graphics clear, like that. And when we play it, boom. Now it moves across the screen at 100 pixels per second. So, so to make this more object-oriented and, well, that kind of thing, let's not put this directly inside of our loop. What we want to do is make a private function called draw. In this we will put all of our drawing code. So we'll just go like this. We'll cut it, paste it in there, and at the end we will draw. So now when we run it, we should get the same thing, just like that. So, I think that's it. I think that's all that we need to get started on our Nature of Code tutorial vlog thing. So, just to show you the core of what we need, let's clear it out. Our draw should essentially just be like this. We'll have our clear, and then in here we'll begin fill, infill will change depending on what we want. We have our delta time thing making that. We won't have the box necessarily, so we'll get rid of that. And we don't need boxy there. So, and we also don't need mouse event. So essentially, excuse me. This is the base of our main, and we don't need boxy here either. Let's delete that. So this will be the basics of what we will start with for our Nature of Hex vlog, tutorial, blog thing. So that's all. I know this was a long episode, and I made a lot of mistakes that I just want to cut out, so we'll see you in the next episode, and we'll start right now ish.